Thank you for joining us this evening to hear about the work of CED, and your very presence here is an encouragement to us all. Just feeling that there are people across the country and around the world taking an interest in what we're doing. And whether you're a CED member or not, you're very welcome. Just to let you know, we have a program that runs through once a month through the winter months, and this year's program runs through to April. We have 2 more talks coming up, I think it is. Today's February, March and April, yes. And they're at 7 o'clock in the evening, 7 o'clock on Thursday evenings around this point each month. And there'll be some sort of flyer goes out before the next event. If you'd like to be included in the email circular, you could send us a message on the chat, and hopefully I'll pick that up. Tonight's talk was to have been on the subject of geographic information systems, and I'm sorry for those who've turned up tonight looking forward to this and everything that would be interesting there, but that's not worked out, and instead you've got my story of my time working on the stabilisation of Christchurch Anglican Cathedral in Zanzibar, which was with CED. My name is Angus Armstrong. I'm a chartered structural engineer and a member of the CED Executive Committee. And as part of that, I'm organising the Tech Talks this season. So thank you to everybody who's participating tonight. Once recorded, all of the Tech Talks are available on CED's website and our YouTube channel, and that should get up tomorrow or the day after. So I hope you enjoy my story. From the beginning. Right, so here we go. The talk tonight, I've given it the title Zanzibar Spice and Why Cathedrals Don't Fall Down. No particular reason, I just quite like the ring of it. But it's Angus's experiences working among the Zanzibaris for a few weeks. Actually, it was spread over a number of years, but the main time there was a period of 5 weeks in 2014. As I said, my name is Angus Armstrong. I'm a chartered structural engineer. I have a business called Addox Structures, and I'm on the board of Christian Engineers in Development. What am I going to tell you about? This is the story of Zanzibar as I have experienced it over an intermittent period of almost 10 years, as we stabilized, well, we investigated and then stabilized the barrel vault arch roof of the Anglican Cathedral in Stonetown on the island of Unguja, in the archipelago of Zanzibar. So Zanzibar is not the town, it's not the island. Zanzibar is the grouping of islands out there on East Africa. It's no technical engineering thesis in any way, it's rather an insight into the lives of people in Zanzibar, as I was privileged to experience whilst working with them, both remotely and whilst there for relatively short spells. Where is Zanzibar? Oh, Zanzibar's off the east coast of Africa. It's off the east coast of Tanzania, and Tanzania is just south of the equator, sandwiched on the coast between Kenya to the north and Mozambique to the south. So we're going to have a little look at some of the broader aspects of Zanzibar, and here I'm telling you about the geology, and you'll find out why shortly. The geology is predominantly coralline limestone. So it's limestone that started its life out as coral, but it is now a type of rock. A little bit of history. It's got a long old history, been occupied for some 20,000 years. It was a staging post for trade between Persia, India, and the Arab traders between the Middle East, Africa, and India. It was one time part of the Portuguese Empire. It was a Sultanate of Oman, and in 1890 it became a British protectorate, for better or worse. It humours me that there was a bit of a skirmish leading to the Anglo-Zanzibar War of 1896, which lasted, 38 minutes, as the British ships offshore bombarded the main town and the guys on ashore decided this was a battle they weren't going to win. So fortunately, they didn't draw it out. 1963, Zanzibar became a constitutional monarchy, but just 1 month later, the Zanzibaris revolted and 20,000 people were killed. And at that time, the People's Republic was established. And in 1964, Zanzibar merged with Tanganyika to form Tanzania, which is quite a nice marriage of names. A little bit on the politics. It's a semi-autonomous part of Tanzania. Zanzibar has its own government, known as the Revolutionary Government of Zanzibar, with the current president being Hussein Mwinyi since November 2020. The history of politics in Zanzibar is not that glorious. They've had various upheavals and revolts and contested elections leading to riots and massacres, killing many people. But I'm pleased to be able to say that in November 2009, the political parties met to discuss how to save Zanzibar from future political turmoil and to end the animosity between them. And there has been relative peace since then. That's interesting. I was first out there in 2007, so that was before they sorted themselves out. Oh, well, I'm here to tell the tale. Expeditions and trade. This is a lovely picture, lovely painting of a traditional Zanzibari dhow, which would be the traditional trading ships. Some of them, you see them just offshore, much smaller versions than this, going out for a day's fishing, and the bigger vessels going out trading across the ocean. It's lying on a crossroads of international trade for over 1,000 years. The main items of trade for Zanzibar are spice, especially cloves, ivory, and slavery. Slavery was by far and away the most important trade, and it's pivotal to our story. We all get pretty hung up in the developed world about the terrors of slavery, and yes, that was bad in our part, and it was bad, but the story here in East Africa was dominated by Arabs, and it ran for over 1,000 years. Slaves were captured or traded in the interior and brought to the coast, many being moved to the slave markets on Zanzibar. And at its peak, some 50,000 slaves passed through Zanzibar every year. 50,000 souls a year. Eventually, the slave trade in Zanzibar was abolished by the British in 1873, which is, in a way, is the start of our story here. This is a sculpture commemorating the slave trade, and it's built in the grounds of the cathedral. It's quite a poignant picture. But why here? Well, Christchurch Anglican Cathedral is in Stone Town. Stone Town is the main town on Unguja in the archipelago of Zanzibar. That's the last time I'll say that. And it was built by British missionaries in 1879, headed up by Bishop Edward Steer. He was a pretty ambitious guy when it comes to buildings. The site of this specific site of the cathedral is on the location of the last permanent slave market in East Africa, and is a site of international historic and cultural significance. Allegedly, the altar within the cathedral is located on the location of the whipping post of the slave market. Additionally, there's a tribute to Dr. David Livingstone in the cathedral, who stayed in Zanzibar before his final expedition. A wooden cross from the tree in Zambia, under which his heart was buried, hangs in the cathedral. Brackets, allegedly. Yes. So 2008, when I was out, I made my first visit and inspection. The building was looking tired. It was suffering structural movement, and so on. When we went back in 2012, once we were starting to make progress, this is picture on the right, things got worse. The roof had started to leak, and this gigantic tarpaulin over the roof. And this building was going one way. If there wasn't major intervention, it would be lost, and that would be a terrible tragedy. So in 2008, when I was there, I was carrying out all sorts of inspections. I was there for about a week, taking measurements, making observations, trying to work out what was going on. And looking at the left-hand side of the picture here, you can see the west gable with the rose window, which doesn't look too spectacular from the outside. It's absolutely beautiful from the inside. It contains stained glass, which is very unusual for building of this period in Africa. You might just be able to make out in the top left-hand picture a line, a crack line running down through that gable wall. And then the detailed picture just below that of the rose window, you can see a fracture running through the rose window. And actually at the bottom of that picture, there's a little gauge monitoring movement in the building. There are other selection of pictures here showing decay. You can see the picture top middle, vegetation growing out of the walls, decay of the detail of the stonework about these architectural arches. And perhaps significantly, if you look at the picture top right, there's this, how would I describe it, this walkway or tunnel. This is right up in the top of the walls. If you look at the picture with the tree growing out of it, these little arches, the upper little arches, are at that level along the straight section of the building. There's this walkway, and you can see either side of the photograph there, the little arches with the daylight coming through. But if you look end to end on that, you can't see from end to end in a straight line. That's because that is curving out the way, reflecting the movement in the walls as the walls are being pushed out. A little more of that later. A plan drawing, for those of you who like plan drawings. Engineers like plan drawings. So I hope you can see my mouse here, but we have the main entrance, bottom left, into the narthex. Above the narthex, there is a raised platform, which traditionally that was where the ladies sat. So they didn't mingle with the men folk who would be worshipping within the main nave here. And then there's a series of steps leading up towards the apse and the altar. Excuse me, I'm just going to mute my phone. It's going nuts on me. Oh, there we are. So we've got a rectangular section that forms the main part of the church, a semicircular end with the apse in it. To the bottom here, the sort of lump sticking out is actually the organ loft, which is a magnificent organ, which I think it came from Glasgow, but I haven't got time to talk about that tonight. And out to the right, we've got the chapel. So this is a little secondary chapel, and morning prayers are held out there, which I went to a number of morning prayers there. I didn't understand a word they said, but it was very special time. And here we've got a long section through the building. So left-hand side, we've got that curved end of the church where the altar and the apse is. Within the bulk of the church, we've got the area where I said the gentleman sat. Difficult perhaps to make out, but this bit here is the raised platform on which the ladies would sit. And these two smaller arches, bottom right, are the main entrance into the building. The series of little mini arches up here high, that's where that walkway was that I showed you a photograph looking down the length of it. And above that line, is the barrel vault arch above. The whole building is a hybrid of architecture reflecting Arab, Asian and African styles, and it's built using coralline limestone, hence our reference to what the island was made of. So lumps of coralline limestone set in lime mortar, the lime mortar having been formed from the coralline limestone by burning it in essentially bonfires. They would burn this stuff, convert the limestone into lime mortar, and it would be used in the construction. Marble colonnades in pairs in between the big arched windows here. Really very nice. It's a beautiful building inside. You'll have to go and have a look at it. This is a cross section through the building, looking towards the rose window. You can see here my little walkway on either side, one either side, and the dotty stuff is the concrete. So this dotty stuff you can see is the barrel vault arch roof, and this ziggy-zaggy black line coming down here is the crack line traced down through the building that we found on site. So in 2008, amongst all of the investigations, I found a contractor who could core the roof and the walls for me. This chap's with the white helmet on is called Savary Nada. I'm still actually in touch with him. What would that be? 14 years later. And some more on him later. Now he got involved because he'd got this clever machine. It's a Hilti diamond coring machine, which aren't 10 a penny in East Africa, as you might imagine. A bit more regular piece of kit here in the UK, but it was ideal for the job. So we cored through the roof, drilled a hole 4-inch, 100mm diameter right through the roof of the church, and recovered this core so we could see what the thing was made of and get an accurate measurement of the thickness of the wall. I have actually got on my desk right now, if you listen, that is this core. I have it in my hands, and I will show you at the end of the talk. I don't want to stop the thing just now. So the picture at the top is the core that came out of the roof. Quite nice, actually, quite dense, well filled with mortar. The bowl below is a core that we took out of the wall on the west gable, and as you can see, compared with the picture above, it's just debris, reflecting the fact that that end wall was not particularly competent. I put my hand into that hole with some trepidation, and actually I found voids within the wall, and perhaps the size of a football. So that wall was not in a good condition. So what to do about it? There's cracks down the wall, the building's obviously moving. What's going on? And I found myself fighting against received wisdom that said it was settlement. You've got cracks, you've got settlement. But I couldn't see evidence that told me it was settlement. And I concluded that it was roof spread. So this big barrel arch vault roof, which I think I calculated weighed 35 tons. I'll say that again, 35 tons for every meter length of the roof. So it was very, very heavy. Towards the top of the arch, the material was about 2 feet or 600mm thick. But at the springing points where the arch met the wall, it was some 1.5 meters thick. So very substantial. And the weight of all that was pushing the walls out, and the roof was coming down. It only come down a little bit by the time we got involved, but that was only going to get worse with time. So just jumping back to this one, the roof spread, you can see I've drawn here, the walls have been pushed out, a crack has opened where the arch meets the wall, and a crack on the underside of the arch on the inside. And this is what we found. When you look up to the underside of the roof before we started the work, we could see that crack line running along the underside of the roof. And then as we started to strip the roof apart, we found the crack on the outside. You can see here quite a substantial crack where the arch meets the wall. And here I was able to stick my tape measure in a foot to 18 inches into the wall. And the little picture down at the bottom here, my 3-pinned arch, that was a little drawing I did on the outer surface of the roof to try and explain to the guys on site what was going on and what we were trying to deal with. But why don't cathedrals fall down? Well, for a number of reasons. Here we've got a slightly more famous cathedral, the Notre Dame, and it's got all these embellishments and looks very fine, but actually these are structural embellishments. All the little ribs and arches coming up, meeting the walls all along the outside, they are abutments. They're holding up the walls and stopping the whole lot spreading out. Alternatively, you could have a truss type arrangement. You think of a roof truss in a house. You've got the triangle of the rafters, and you've got a tying member forming the ceiling, and that ties the whole lot together. But Zanzibar Cathedral had none of that. And I did calculations to try and understand why Zanzibar Cathedral didn't fall down. And I couldn't understand why it didn't fall down. It wasn't that the numbers were a little bit out. It was the numbers were way, 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 way out. With the cracks that had formed and the outward force that arch was now exerting on the walls, it should have just pushed the whole lot down. But what I concluded was that what was left of the roof was acting like a great big diaphragm to shed those walls out to either end, to the west gable and to the domed apse. And with these two walls either end that were actually holding it together. The unfortunate thing is that, as we discussed earlier, the west gable now had a crack running down it, and that crack was widest at the top and tapering off towards the bottom, and clearly that wall was being ripped apart, and we know already that wall is very poor. So my proposal was to tie the arch together to stop it falling apart. And so the proposal, you can see on this is one of my design sketches, was to introduce these ties, the blue line across just below the arch there. They would go in at 2.7 meter centers. I think we stuck 10 of them in. They were 1.25 inch stainless steel bar, or 28 millimeters. They went through a hole drilled through the bottom of the arch there, and were anchored into a cast concrete thrust block on the outside. We wanted the thrust block because obviously the coralline limestone and lime mortar was not particularly strong to take these high concentrated stresses. So we put in a thrust block to distribute the stresses out between it. And so who were the team? Well, CED was kind of first on the scene and working with the Anglican Diocese of Zanzibar. And we had identified the problem, we had identified what we wanted to do about it, but financing it was a challenge. And things rather stagnated for, possibly as much as 7 years. But the chappie in the middle here, Father Jerry Kramer, and his wife, his wonderful wife, Stacy, became, I think their title was Special Vicar of Zanzibar. And he's a remarkable character. He's now working in Syria, I think it is, working with refugees from ISIS. And he had previously been in, I think it was Philadelphia after Hurricane Ida came through and caused devastation there. But again, we won't go into that sub-story just now. And he, I don't know how he got hold of them, but he got in touch with the World Monument Fund. And if you're interested in this sort of thing, go and research the World Monument Fund. They have been involved in all sorts of most wonderful buildings around the world, getting involved in restoration. And they were able to get involved with a European fund and got best part of €1 million for the project. And so that was the team: Anglican Diocese of Zanzibar, Christian Engineers and Development, and World Monument Fund. And my company, Adax Structures, my element of the work, I did I did through that on behalf of Christian Engineers and Development to make sure we got the adequate insurances and whatnot. So we'd got the design, we'd got the money. I'd ordered up an assortment of materials, including these stainless steel rods. And I bought a flight ticket and out I went. And I was very, very pleased to get there and find that stuff had happened, because it wouldn't have been beyond the bounds of possibility to arrive on site and find that the place was still fully occupied and worshipping services going on. But no, they were there. They've got the scaffolding up. And I don't know what you think of the scaffold, but this here is, for Zanzibar standards, this is the Rolls Royce. For UK, it's a bit dodgy, but the more typical scaffold in a building like this would be what I would call sticks and string. So they would take long poles of boriotti trees, in the case of Zanzibar, and tie them together with a kind of a hemp rope. But I wasn't too keen on that. And so I was pleased to find this. The other thing I was very, very pleased to find when I got to site was a very large crate, some 7 meters long, with all my toys in that I'd ordered up in the UK. So that had come out from Sheffield with the various stainless steel components that I needed. So we got to site, we got our contractor. So we got involved with Savary Nada, the gentleman that you saw on the roof there in 2008. He was to be our contractor. He had agreed to do it. He had agreed what he was going to charge us for the work. And we all met up on site. And what we were going to do was drill a hole through the wall, 4 inches in diameter, 1.5 meters long. And that had to be square to the wall and line up. And what's more, and significantly more difficult, it had to line up with the hole on the other side of the building. So we had to drill another 1.5 meter hole on the other side to thread this bar through. And pretty much you want to be able to stand on the outside of one and see right through the outside of the other, because otherwise we weren't going to get that bar through. And it was almost instantly apparent to me that this Savary Nada hadn't got the first idea how to achieve that. And it probably would have gone horribly wrong then and there. So I intervened, and my expectation of the job was that I would rock up here in Zanzibar, meet the contractor in the morning and say, wave my arms around a bit and be expressive about some profound matter or another, and then leave them to get on with it while I went swimming or fishing or doing something nice, and then maybe come back in the evening and tell them how clever they'd been or otherwise, as the case may be. It turned out I was flat out every day, 6 days a week for the 5 weeks I was there. And I got to say, I was pretty tired by the time I left. Here, this is a little tripod. I don't know if you can see it. You probably can't. But on it, there is a little laser pen, little laser pointing device, the sort of thing that throws a red dot onto the wall when someone's talking to you. And for some obscure reason, I bought a clutch of those just before I left the UK for £1.99. And it was pivotal. It just made what we had to do possible. And was probably the best investment I've ever made in my life for £1.99. I subsequently went round Zanzibar buying up Zanzibar's stock of AAA batteries, which the traders were very pleased about. So here we are inside, trying to get on with the work. Savary Nadi and his sidekick with his Hilti coring machine drilling the hole. So he had made up this green framework you can see him holding on to there. And it seemed like a good idea, but when we tried to use it, it just turned out it didn't really work. The vibrations off the machine meant it didn't work for us. And so it took a lot of time to get going and drill the first hole. And it probably took as long to drill the first 5 holes as it did to drill the remaining 15. But we did. We achieved that. We got them straight. We got them level. We got them lined up, and very satisfactory. Here's a typical hole. So I would mark out this red cross on the wall. He would line up his device. I would align the device with my laser pen on the other side of the cathedral, and off he would go drilling. And here we've got daylight through the other side. And the bottom picture there, you can see the various bits of debris that come out of the hole. And across on the right-hand side of the picture, you can see the detail of what we're doing. You can see the rod coming through the wall. The dotty lines are the hole that we've cored, and there's the green bit is the concrete thrust block that we were casting. And just below all of that, you can see this walkway that I've mentioned a few times. So here's a collection of pictures of the process, really. So starting top left, we've got the guys cutting out the pockets on the outside, hammer and chisel, chipping away in the hot sunshine. I tell you, out on the roof in the heat of the day, standing on that roof was not a place I was very happy to be. And if between me and the shade there was some obstruction, I was pretty unhappy because I spent the minimum possible time exposed to that level of sunshine. So once we got the hole cored and we'd got the pockets cut out, we then set up a little shutter, a bit of plywood to contain the concrete, and ran the rod through. And you can see the rod coming through just below my hand there. Make sure that the shutter is vertical and the right shape, the right size. Top right, we drop in a cage of reinforcement. Again, this reinforcement was stainless steel bar, imported from Sheffield. I wanted it to be stainless steel because I wasn't sure what I was going to get out of the concrete. And this Stone Town is a port, so it's by the sea. We could have a salty environment, and corrosion was a concern, so we used this stainless steel reinforcement. And then down the bottom here, we've got Stuart. We'll meet Stuart again a little later on. I quite liked Stuart, but he was a little bit of a character. But he was mixing my concrete for me, and we were very careful with mixing the concrete. We weighed out the constituent parts and mixed them up carefully, and tipped it out into a bucket. This chap in the middle picture at the bottom came across with a bucket, put it in the bucket, hoisted it up, took it along. This is a picture of Tony podgering the concrete into the hole, so that means stamping it down to make it consolidate. And then the chap would take the bucket back, lower it down, the other chap would pick the bucket up and go back to Stuart and get another bucket of concrete. And I watched this for a few minutes and thought, this is going to take forever. So I suggested, how about we use a few buckets? Which was like lights going on with these chaps. I said, oh gosh, that's a good idea. And the whole thing went a lot quicker. But now we had a problem. I quite like this bit of the job. So we got, because we couldn't put the rod right the way through from one end, partly because we couldn't suspend it out over the outside of the building, and partly because there was an upstand wall, we got the rod in three parts. There was the middle part that was 6 meters long, and there were two shorter parts that were 3 meters long. So here's a little picture of the arrangement. And one Friday night, I said to the contractor, I set the 6 meter rod up on two stools in the cathedral and got one of the shorter bits of rod. I set the shorter bit of rod on a chair, horizontal, and I said, now, I want you to do up the coupler that joins these two bits of rod together, because the ends of the rods were threaded. But you're not allowed to touch this. You're not allowed to touch the middle of the 6 meter bar, because once you're up there, you won't be able to get to it. How are you going to do that? And because of the span of the 6 meter bar, there's quite a droop in it. And so the contractor looked a bit puzzled and went off for the weekend and did whatever he did over the weekend. And Monday morning, I met with the contractor and eagerly awaiting his comment. I said, well, right, okay, how are we going to do it? And he said, well, it's not possible. What do you mean it's not possible? You're the contractor, you're supposed to know how to do these things. He said, it's not possible. I said, well, you're going to have to build a scaffold or something up the middle to support it. And he said, well, I'm not paying for that. So obviously this chap's understanding of a contract was a bit different to what we might understand in the UK. Obviously we were going to have to resolve this problem for him. So myself and Tony, the stonemason, the chap with the red shirt earlier on, came up with a plan. which was to put a bridge across high up at the location where the first bar was to go over. But we couldn't build it up there because obviously it was up in the air, and we were going to have to lift it up. And to lift it up, we could only use manpower, and so it had to be light. And so this was my construction, to build as light a bridge as possible. So I got some 8x1 or 200 millimeter by 25 millimeters, some two pieces joined together, forming a plank that was about what would be 8-9 meters long. And the chaps on site laughed at me. They said, "Well, that's never going to work, is it?" Because as you can imagine, something 9 meters long that's 25 mil thick is very flimsy. But I rather, was it arrogant? I don't know. I said to them, "Ha ha, but I'm going to do some engineering magic." This was the fun part. So we took two of these long planks side by side and braced them up, as you can see, with these various bits of timber here. And it worked a treat. So this is a picture of me standing on it with a huge cheesy grin on my face as my plan was coming together. So we hauled it up. I had to leave the building at this stage because it was just too scary. And now let's see if it works. So this is the bridge in place. And Tony's part in this cunning plan was what we called the mouse, which you can just see right in the middle there. There's a vertical something. And if you look carefully, you'll see a piece of rope going down to the bottom of the something. Waiting for the next, there we are. So the something you can see now in this picture is this piece of wood with a V-notch in it. And you can see the rope going along. And the rope goes along, goes over a runner down to the bottom of the plank. And when you pull the rope, the plank with the V-notch rises up. So we would position a rod on the bridge, center it on the bridge where the V-notch was, and when we wanted to lift it into place, we'd lift it up, pull the rope so the middle of the rod was supported, and bingo, it worked. So there are this. That's the mouse fully raised up.
Is this the joint?
And there's one of the rods successfully installed, and you can see there on towards the left hand end the coupler joining the two bits of rod together. Yippee! It worked. So here's a few pictures of detail. Sort of middle there is the rod coming through my concrete thrust block, and we also had a steel plate on the outside to distribute the stresses into the concrete. I don't know if you can see a black something there. There's a bit of a square of neoprene to soften the stresses between the steel and the concrete. And bottom left here, this is Savary tightening up the bolts on the outside. So hand tools, an 18-inch spanner, and they just tightened these up. And as I've said earlier, the rods tended to droop. But as you tighten them up, you could watch, and you could just see that rod zip up into the horizontal position. Now, I'm sure if you made precise measurements, there would be a tiny deflection on it, but to the eye, they all looked horizontal. And interestingly, I had been closely monitoring the building for movement because we were bashing it about a bit, and I was concerned that the movement might accelerate. And I was monitoring the width of the inside of the building. And I measured it the day after we put the rods in, and I found that we'd pulled the whole roof together by 2.5 millimeters, which, bearing in mind, as I said earlier, the roof weighs 35 tons for every meter length of it. I was quite impressed by that. And here's a picture taken just looking along the line of the rods. And don't know about you, but I was quite pleased with this. All the rods, they're level, they're straight, they're parallel, all the couplers lining up. That was a good job. I was pleased with that. Now, we did have an issue with the concrete. Well, not so much with the concrete. Because we wanted to stress this concrete quite early in its age, normally concrete would reach its design strength after 4 weeks, 28 days. You talk about the 28-day strength of concrete. But I designed a strong concrete with the hope that it would reach a decent strength reasonably quickly. And so we made concrete samples, which is what you do in the UK to test structural concrete. So we were making these samples in these special steel boxes and taking it along to the Kirumi Technical College, which is the picture on the left there, where they have a crushing machine and they would crush the cubes. And that's what we do in the UK. And they'll tell you what the cube crushed at, and hence you know the strength of your concrete. And we were getting superb results. I was very pleased with myself because I'd designed the mix. It was all site batched. I thought I was a terribly clever engineer. But then time went by and we were getting all these great results. And I was thinking, this is a bit of a free lunch. In other words, there's no such thing. And I began to doubt it. I thought perhaps the really hot conditions in Zanzibar made the concrete gain strength faster or something. But anyway, we decided an independent check was required. And the French were in the process of extending the runway in Zanzibar. And as part of that, they had a whole laboratory, including a very swish concrete crushing machine. You can see it in the middle of the picture on the right, the little framework in the background. So we made a set of cubes. We made them at the same time, from the same concrete, in the same way. We stored them in the same way, and we sent them off to be crushed at the same time. And surprise, surprise, Kirumi Technical College told us we'd got this wonderful concrete, and the French machine crushed out at what we would have expected. The concrete was fine, it just wasn't astonishingly good. So everything was okay, but we had greater confidence. It turned out that the guys who calibrate the machines had come to the island and calibrated the French machine, but the Kirumi Technical College hadn't bothered getting theirs calibrated. And the money we were paying to crush the cubes would have paid for the calibration several times over, which was a bit frustrating, particularly as we were aware that there were other concrete works happening in the town of Stonetown, and there was a large hotel being built by the Chinese. And I believe they were having their cubes crushed at the Kirumi Technical College. So I think I'll not bother to go and stay in any Chinese hotels if ever I go back to Zanzibar. Here's some picture of the team. You work with a bunch of people for a time and you grow a bit of a heart for them. So key players here, really. Here with a big grin and the red shirt is Tony. He is a British stonemason, although lives in Africa now. And he has worked on numerous wonderful projects around the world involved in restoration. And he's also worked on some of the big English cathedrals. Behind him there, again with a big grin, is Vua, a local tradesman. He was first rate, really good guy, very good work ethic, skilled man, and a valued member of the team. Savary there, sitting in front of the altar, a very fine altar within the church. The local contractor chappie there, he didn't do anything for our project specifically, but he was a Muslim neighbor to the cathedral, and he was just really nice, really help. If he could do anything to help, source materials or so on, he would help us. And he took me out one day and drove me around town, showing me his various construction projects, and it was really nice. I met this garage mechanic, bottom right. He was just across the road from the cathedral, and if I needed something made up to help with the project, he would make stuff for me. And at the back of his garage, he'd got these wonderful, great, big, old iron metalworking machines, of which he was very proud, and they were being manufactured probably in the Victorian era, I don't know, in England. And then top middle, we've got Stuart again. Now he wins top prizes for the only guy that I know that could snooze comfortably in a wheelbarrow. This particular day, I had set him tasks to do and around the back of the cathedral, and I was working around the other side, and I came back some 3 or 4 hours later, and nothing was done, but plenty of Zeds had been had. Another picture of the team, just more characters here. You knew them all by name, and we'd shared the ups and downs of the project, and you really felt quite attached to them by the end of the job. In the background there, incidentally, is the main entrance to the cathedral. I don't know why we've got two doors, maybe one for the ladies, one for the gentlemen, I don't know. But very fine wooden doors. It's a feature of Zanzibar. They have many of the old buildings have got the most magnificent doors, and many of them have got great big pointy brass studs sticking out of them for some reason or another, some sort of defensive reason. One of my great frustrations through the project was health and safety. People's understanding of health and safety is shall we say, different when we get to Zanzibar. And one of the problems was that the tour guides for the site persisted in bringing groups of tourists into the building. Now, you imagine I'm working up at the top of the scaffold with a 6 meter long stainless steel rod that's 1.25 inch diameter that weighs many kilograms. If we were to drop that from that height, it would have skewered one of these guys to the ground. And I told them again and again they mustn't do this. And we had meetings and they agreed, and then they just did it again. Very frustrating and worrying. So I was there in 2008, back for some planning meetings in 2012, for about 5 weeks in 2014 when we implemented the structural stabilization work. And then back again a little later, we'll come on to that for the grand opening. But the project was much bigger than just stabilization. There was general renovation of the whole building, cleaning the outside of the building, putting on new roof tiles across the whole building. And they also built an exhibition center focused on the subject of slavery, which I believe is a great success, but a very sensitive subject actually in Zanzibar. On the left here, you can see what I mean by sticks and string. Once they got onto the work on the outside, these guys were quite happy to clamber around this open scaffolding. No boards to walk on, no handrails, and it's all held together as sticks and string. But I believe we achieved the project with no accidents. Incidentally, if you recall that one of the very early pictures of the cathedral, it looked kind of black, which is kind of an algae growth, and they cleaned the whole thing. I haven't actually in my presentation got a very good picture of the final church, but they did clean it all, and I'm told they cleaned it with shaving brushes. Yes, shaving brushes. They had a squad of guys, and they had to work meticulously and very carefully, and they would clean away with a shaving brush and work their way around the whole building. So you can imagine how long that took. And this is my last slide. 2017, I was invited back for the great celebration, the opening, and the Zanzibar, or the Tanzanian television cameras were there, and there were two magnificent, great African choirs singing, and all the officials were in their finery, and the place was packed, and all the people attending, they turned out in their very finest clothes, and it was wonderful. I can't tell you. It went on for quite a long time, as African services tend to. But the choirs sang just so beautifully. And I've just got to say this. If you look at the picture on the left with the words "Great Celebration," well, just above the word "Great," you'll see a line going across the picture. Well, that's one of my rods. That's holding the building together. So thank you for bearing with me. I hope that's not been too long. And I'm going to stop sharing my screen now and open the things up to questions and answers. Welcome to unmute yourself. And if you want to make any comments or ask any questions on what we've been talking about, you're very welcome to do so.
Angus, can I ask you, do you have any idea what sort of load went into those rods, either by calculation or by measurement?
Yes, but I don't keep it on the tip of my tongue.
Okay.
My folders.
I was just wondering, how hard those rods were working. They seem to be quite slender to me. Well, I presume they were They were stainless as well, were they?
They were stainless.
Yeah.
That was a 28 mil rod. Can't remember what grade it was, but I mean they're not carrying the 35 tons. They're carrying the sort of horizontal component of that truss section. But yeah, there was a reasonable amount of load in it.
Yeah. My experience of stainless doing up connections under load, there's a real risk of a friction weld developing. Did you have any trouble with that?
Oh well, we weren't doing them up under load. I suppose we were talking.
Right. Okay.
The couplers were done when everything was loose.
The
bolt on the outside was done up. It progressively attained load as we tightened them up.
Yeah.
What we did do, there was a concern that the opposite might happen, that the connections might work loose. So we used a special glue, a stainless steel glue. It's sort of blue stuff. Can't remember what you call it just now, but I took that out with me as well.
Yep.
Before I forget, that's an offcut of one of the stainless steel rods. So these were in at 2.7 meter centers, and this I like that, but this I really like. This came home in my suitcase. So, so you can see the matrix of the material. There are some voids in this, but there's a piece of coral here and the lime mortar round about it. And there are actually that little black bit there. There's a little bit of charcoal from the firing process, from what they called a tannu when they were making the lime mortar.
Angus, I was just interested in how you managed to lift the rods up to that level. Were they on the bridge as you lifted the bridge? You lifted the rod on?
No, we'd lifted the bridge into position, and then we'd tie a rope to either end of the rod, and there would be people on both sides, pull it up, position it on the little bridge, and progress like that.
Okay. So the weight was manhandleable then, really?
Yes, yeah. You just wouldn't want to drop it end first on top of someone at ground level.
No.
Never mind going through the people. I think it would have gone through the floor.
Angus, question about your starting point. How hard did you have to work to get your roof theory as opposed to settlement?
Well, the other guys that had looked at it were surveyors or architects, and not engineers or not structural engineers. And so I did meet with a bit of resistance. And in some ways it's easier to go with the flow, but if you see settlement in a building, then you might expect to see cracks rising up from ground level, perhaps most typically diagonally, and it just was. I wasn't seeing that kind of evidence. Plus, when you did a plumb survey, you dropped a weighted line down the building and measured the offset. It was very clear that the walls were leaning out. Again, John will want to know how much they were leaning out, and yes, I know, but it's in a folder somewhere. And also you eye along the length of the building, and you could see that there was not only was the wall leaning out, as we saw in that picture looking along the little corridor, the whole wall was bowed from end to end, where it's to some extent it was being held in position at either end by the end walls, and the middle was bowed out.
Thank you.
Mm-hmm. Alan. Oh, Alan, you might be muted. Or something. You don't look as if you're muted, but I can't hear you. You could try typing your question down at the bottom of the screen. If you move your mouse to the bottom of the screen, you'll find a little chat facility.
While Alan's doing that, perhaps I could ask a question.
Yes, Jonathan.
Were there any drawings, either, of any degree of the plans and elevations of the cathedral as built?
Well, what I haven't said, and it's a great omission, is I haven't mentioned Ian Rankin, who is a CED member and a member of the executive committee. He is first, well, his qualifications as an architect, but he works with CED and does engineering stuff as well. He's a good all-rounder. And he had done drawings of the building, so we've got those. But also I did a lot of measurements and prepared drawings while I was on site. Now, Alan, would a parabolic arch have worked better? Well, even with a parabolic arch, you still would have developed thrust at the where it met the walls. So it probably would have been better, but I don't think it would have been the answer to the problem overall. Because at the ends of a parabolic arch, you still have a horizontal component force.
Angus, it might be worth mentioning the book by Jacques Heyman, The Stone Skeleton. I don't know whether any of you are familiar with that book, but it's a very seminal work on vault structures, masonry vaulted structures, and has some wonderful references and examples.
Okay, Jack what?
Jacques Heyman. So it's Jacques as in French Jacques. Jacques, Heyman, Heyman, and the book is The Stone Skeleton.
Okay.
He's a professor at Cambridge. He's a very, very clever chap. But it's an excellent book. Excellent book.
I'll look that up. Thank you.
Angus, did you have any problems that we have in the UK and certainly in the Anglican Church of obtaining a faculty for doing any of the work, which is a kind of permission from the church officials?
I certainly didn't. Now, one of the church officials was a chap called Nuhu Saliana, who's still out there. I really like Nuhu. And I subsequently travelled a bit with him as we went to look at another project down towards Mozambique. And I was actually speaking to him earlier today. But he was, I guess he was our local fixer. If we needed something sorted, he seemed to have contacts with all sorts of people and could get stuff fixed. So he's gone on to do various things. His current project is to try and raise funds to send 3 local promising girls to further education beyond what they're doing just now, both to have girls in education and Christians in education, and to benefit Zanzibari society. I haven't told you so far, but the Christians on Zanzibar are very much a minority, some 5% versus 90% Muslim. And another 5% of odds and sods, very round figures. And the Christians are somewhat of a marginalized community. And that's one of the reasons that the cathedral is important, because it contributes to security for the Christians, because this cathedral is a very important tourist attraction, both because it's a fine building, but more significantly because of its association with the slave trade. And the government and the powers that be are very keen to see that environment endure and be stable. So, if there should be trouble on the island, then that's kind of a bit of a protected zone. So, yeah.
Yes, another question, Angus. In some of the earlier pictures, when you were diagnosing the problem and you realised where the cracks were, you showed us the sketch. After you had put in your skeleton, stainless steel, and tightened it up as much as you judicious, was there any treatment to where the cracks were?
Yeah.
Were they left?
Yep. So Tony was involved in grouting up any and all cracks that he could find, both the ones that we've seen in the roof, but perhaps more significantly down the gable wall. So he would drill into the wall, introduce a bit of a pipe and pour a fluid grout mix into that. I believe that was a lime mortar based grout, which would be appropriate to a lime mortar type building. And he did a lot of that work as a stonemason more rather than under engineering guidance. So that happened after I left. And also pinning the crack line through the west gable. So he would introduce, I believe, clay tiles to bridge the crack at a number of intervals throughout the height, and that was a kind of recognized methodology within his trade. It was one of the challenging things about it was translating what we would do in the UK and materials that were available in the UK and methodologies to what was practical and realistic in the local context. One of the things that shocked me and actually saddened me was some of the tools that were available. Two examples. One was a spade and one was a drill. So we went one day and we needed a drill to drill through 1/2-inch plywood. And we bought a Matika drill bit, a spade drill bit, the flat ones with a sharp point at the end. And it was blunt after we'd drilled 2 holes through a piece of plywood. It was not Matika at all. It was a piece of rubbish from, dare I say it, China. And similar with the spade, they spent their money, they got the spade, and they went to dig a hole, and the spade was worthless at the end of the day. And the reason it makes me sad is that the meager funds that they have, they spend on something, and by the end of the day, they don't have the money and they don't have the tool. Same can be true in this country to a lesser extent, but in that context, it made me a bit sad.
I think a lot of the better goods are aimed at our country in terms of exports, from what I've heard, and Africa tends to get the much lower quality exports. Yes. They can't afford anything more, which is sad too. Yeah.
So in that context, that's why we exported the stainless steel. So we knew what we were getting. We knew we would get the proof stress we were looking for. It was a concern for me with the cement, actually. What was I going to find that I was trying to make concrete out of a mixture of charcoal and flour paste or something? But as we said earlier, the concrete did set well. Later on, they were trying to use plaster for something, and it didn't set. Well, if we've no other questions, I'll just say thank you very much for listening to the story of Zanzibar. I've enjoyed being able to tell it again, and also to remember it again as you sort of go over it and think about it. It pulls up fantastic memories. It was whilst I was very pleased to come home to Scotland, within a couple of weeks, I would have gone back to Zanzibar in a flash. It's an amazing place. And even now, if you hear on television, perhaps the call to prayers, the Muslim call to prayers, it sends a tingle down my spine, because that would happen every morning before I was properly awake, and every evening. And it's quite. Hang on a minute, Alan's typed something else here. Forged wood chisels out of scrap bicycle parts, which were better than the. Okay, so Alan's saying he forged wooden shuttles out of scrap bicycle parts, and they were better than the Chinese imports to Uganda. Yeah. Yep. Oh, well, that's. Was that you typing? Congratulations on your innovation, Alan. I think you're the guy that gets congratulations for innovation there. Very good. Yeah.
Some of us in CED have known Alan a very long time, and he will innovate almost anything.
Very good. I love innovation.
One of the best early pictures of CED's practice is a plaque, which became an earth moving tool, which he used in repairing a dam in Uganda somewhere.
Okay.
He developed this device which could be pulled by a couple of oxen, and was just as good as using a scraper or something like that. Alan's great at that, and if he says that you've done a good job with your fabrication of tools, I'm sure he's right.
Yep.
By the way, just in passing, the Japanese name Makati has a Swahili, Matika has a Swahili anagram, Makati, which means bread. And perhaps that tells you something about the quality.
Yeah. Good. Okay. If we've not got any more questions or comments or stories people want to share, I'll draw this to a close and just thank you again very much for joining us in tonight. Faces well kent and less well kent, and maybe we'll see you another time. Next talk, I won't actually be here. I'll be out in the Alps somewhere. But the next talk is CED and climate change, and Rob Wakeling here is going to be speaking to that subject. We'll have to find someone to compare that one, Rob, unless you want to do it. And the month after that, we've got Alan, who's going to sort out his microphone before we get there. Because it's going to be a long talk if you're going to type it all as we go along. Alan's going to be talking on sanitation in the developing world, which will be very interesting as well. So, and Alan's talk will conclude our group of talks for the year, and then we hope to pick up again in October or November at the end of the year. So, thank you very much again for attending, and good night.
Yeah,
Thank you very much, Angus.
Right,
Thanks, Angus.